let's suppose this is a curved surface or a container in which I have placed a particular amount of liquid. Okay, this is the solid boundaries which is in the curve form, and we only interested to understand how much forces apply on here and where is the resultant force apply by the liquid in this curved surface. So if we consider here this surface, around this definitely the weight of the liquid present in that particular volume acting on downward. A part of that, if certain mass of liquid available here at upper part of this curved surface, definitely we have to include that one as well. The horizontal surface, the horizontal forces that are acting along this curved surface is equal to what they are acting along this particular area. Okay, so it's something, the figure is like that, and this is the center gravity point at which the whole body concentrate on it. So if I talk about that, where is, let's suppose this is the FR anywhere, which can be determined by its two component. FR is equals to under root of FH square plus FV square. Okay, if we know both these components, we can easily determine what is the resultant force. On the other hand, if we want to know that how much angle at which it is applying pressure on this curved surface, so which can also be determined by the simple method of tangent inverse of FV over FH. Now the matter is that how can we determine FV and FH? FV is the vertical force. Okay, so let's suppose F1 is the force that is present at the upper part of this surface, and on the other hand there is a weight present of the whole liquid weight which is acting on downward. So if we only consider the vertical force component, so we comes to know that FV will be equals to the sum of F1 and W. On the other hand, if I will talk about FH, so FH will be similar what the force act over this plane surface. Okay, because we have discussed that the pressure only changes with the height, does not changes with depend upon the the shape of the body. So we only what we have to include it what we have determined the FR in plane surface. So similarly it is nothing just equals to the specific weight of the fluid multiplied by the area at which it is applying, and multiply by the HC value, and HC is different for different system. Okay, so this is the basic formula. If I will talk that let's suppose this is the H value and this is the B value, the breadth, so it can be further simplified as fluid area can be written as H multiplied by B, and HC retain its position as this. So for that we have to determine HC, FH and FV. Once we determine these both components, we can easily determine the resultant force. we can easily determine the angle of where this is acting along with respect to the x-axis. After that, we have a numerical in which there is a 6 feet diameter drainage conduit as shown in the figure, and it is half filled with water and the water is at rest. Okay, determine the magnitude and the line of action of the resultant force. So we have to determine the resultant force. The water exert on a 1 foot length on the curved surface BC. You can see here, this is the curved surface. We have to consider only along B and C, and which I have developed a diagram here in the whiteboard as well of the BC cross section as well. And we know the length of the pipeline is along 1 foot, so we have to determine here in this way. The radius at which the fluid is half foot, which is equals to 3 feet, and definitely what will be the HC, half of this R, which is equals to 1.5 foot. Now I just only convert foot into meters. R in meters has this value 0.9144. The width of the pipeline or the length of the pipeline becomes equals to 0.3048 meters, while the SC value becomes equals to 0.4572 meters. And we know that what is FV? FV is nothing, F1 plus the W. On the other hand, if I will talk about what is FH, so we know that which is nothing, just equals to the specific weight of the fluid, the area, or I directly reduce this area, so I can write here R multiplied by B multiplied by HC. So these are the two formulas we know, and if I will solve it for FV, so I know that there is no fluid mass present at the upper part of this curved surface, so F1 will be equals to 0. On the other hand, W, the weight of this confined volume will be equals to the specific weight of the fluid multiplied by the volume here of this complete system, so which is equals to 1/4 of a cylindrical volume. Okay, so I will write it in that manner, 1/4 of pi R square and H. H is actually B. So I reduce this formula in that way that it is 1/4 volume of the cylindrical volume of this particular system. Now I just have to put the values in order to determine the answer. 9810 multiplied by 1/4 multiplied by 3.14 multiplied by R square is nothing, 0.9144 whole square, and multiplied by the value of B is 0.3048. Okay, so we have these values in front of us, and the net result is equals to FV, so I have calculated 196.57 newtons. On the other hand, if I will talk about what is FH, it is nothing, just equals to this value, so I just put values in the formulas like 9810 multiplied by value of R is 0.9144 multiplied by the value of B, which is equals to 0.3048, and the value of HC, which is equals to 0.4572. So we come with a value of around 1250.05 newtons. Then with respect to this, we can easily determine the value of Fr and the value of angle. So I retain Fv and Fh value in the whiteboard, and Fr will be simply equals to Fv square plus Fh square, and the value is for Fr will be around 2326.87 newtons, and for angle it will be just equals to tangent inverse of Fv and Fh, and which implies that theta is just equals to 57 degrees. So we comes to know that the angle here Fr has a magnitude of 2.3 kilonewtons and has an angle with x-axis 57 degrees. So this is the way we can resolve for a curved surface. Then we have another numerical in which the figure is shown here. H1 is actually the height here from upper part to this part, and we have to determine the resultant force along this curved surface. Okay, so I have made a diagram here in front of you. So it is something like that. Everything is on SI system, so I don't need to solve it or convert it. On the other hand, they have also described that the fluid is water here. You can see 9.81 kilonewton per cubic meter, the specific weight of liquid. So we know the two formulas. Fv is nothing, just F1 plus the weight of this part. Okay, then we have Fh. Fh is nothing, just the specific weight of fluid. Area here is equals to R into B and multiply by HC, and HC we have to determine with respective way. So here first I will solve it for Fv, which is equals to F1 plus W. Now F1 is something, the mass of the weight present at the upper part of this curved surface. Here you can see. So you can determine the force F1 by again using a specific weight relation multiply by the volume, and volume here will be equals to just length, width and height. So we know this is B, this is H1 and this is R. So we multiply here for F1 as B multiply by R multiply by H1 plus the weight present at the curved surface. So for that again we have to use the specific weight relation and the volume of the liquid here. So again it will be equals to the 1/4 part of the cylindrical volume pi R square into B. So now I will just put all the values here. 9810 multiply by the value of B is 2.5, multiply by the value of R is 1.5, multiply the value of H1 is 3, and we have to plus it with a specific weight 9810, multiply by 1 over 4, as it is 1 over quarter part of the cylinder, multiply by 3.14, multiply by R square 1.5 square, and multiply by the value of B, which is equals to 2.5 here. So we come up with a value of FV, which is simply equals to 153.7, and I have converted in kilonewtons. Okay, so just by using these values you come up with the solution value in newtons. I have converted in kilonewtons directly. After that, for FH, I know all these values except HC, and HC will be equals to H1 plus half of R. So I can write here H1 plus R divided by 2, which is equals to HC. So just put that one in this equation here. Okay, let's suppose I have right here HC is H1 plus R divided by 2, and I have to put all the values here in respective way, that R is 1.5, B is 2.5, H1 is 3, and R is 1.5 divided by 2. So this HC will be equals to around, I did not calculate it, I direct calculate the FH value, so which is simply equals to 137.95 kilonewtons. Okay, so after that you can easily determine the value of FR and theta by using respective relations. Of FR is nothing, just equals to FV plus FH and their squares, and its magnitude is equals to 206.53 kilonewtons FR. And then I have to determine the angle, which is nothing, just equals to the vertical component and horizontal component, and when you take these values you come up with a solution value of 48.09 degrees here. So we comes to know that the FR is acting along this manner, which has a magnitude of 206.53 kilonewton and has an angle of 48.09 degrees with the x-axis. So this is the way through which you can resolve the solution and determine the resultant force for a curved surface and the position of the resultant force with respect to the x-axis, which is a very simple method, I think.